just before your exam, just before your first date, or just before your public speaking gig? Have you ever had to run to the toilet because you couldn't hold it in any longer and you were just like, oh my gosh, it just needs to come out. I can't control my nerves. I can't control my anxiety. I can't control my stress. I need to go to the toilet. Or have you got those butterflies, that feeling in your stomach when you've been anxious or stressed? Well, the thing is, you're not the only one because it is in our genes, it's in our body. There is a connection between our brain, our head, and our stomach, our gut. It is called the brain-gut axis, and it impacts more things that we can even think about. And it's called, like I said, the gut-brain axis, and there is a connection. There is a connection between your brain and your gut. And that is exactly what I'm going to be talking about in today's episode. I'm going to be talking about the gut-brain axis, what it is. What is the gut-brain axis? And then I'm going to talk about the effects that stress has on your gut. And then to wrap it up, like I always do, is I'm going to give you tips on how to control this. Let's get into it. It's Mondays with Mihaela. That's right, me. Thank you so much for tuning in. I love, and appreciate your support. If this is your first time listening to the podcast, watching this on YouTube, my name is Mihaela. I'm a qualified naturopath, and I'm absolutely passionate about all things health, business, and overall success. And in this segment of Mondays with Mihaela, I'm here to provide you with simple, savvy, and sustainable health hacks to optimize your health. And in today's episode, I want to talk about stress and the gut, how stress affects your gut. Does it affect your gut? What happens? Let's get into it and find out. First of all, to start off, I want to be talking to you about the gut-brain axis. Yes, you may have heard of it before because a lot of individuals are talking about it because, we don't think there is a connection, but there is such a strong connection. When we are stressed, it impacts our gut function. It's like a highway. It's a communication up, down, always communicating, always talking to each other to get us to optimal health. Well, that's what our body wants to do at all times. So let's talk about what is the gut-brain axis. Let's get into it. Well, to start off, stress stimulates the release of a number of hormones, which in turn stimulates the secretion of cortisol from the adrenal cortex. I've spoken about this a number of times. When we're stressed, we get a rush of cortisol in our body. But not only that, the stimulation of this sympathetic nervous system in response to stress causes the release of also adrenaline and noradrenaline from the adrenal medulla. So neurons of the sympathetic nervous system supply the entire gut directly via the vagus nerve. Okay, so that is where the connection is. Keep listening. This is so interesting. I love it. So it also provides parasympathetic input to the upper gut, to the distal colon and rectum respectively. The afferent and afferent neurons, up and down, of the sympathetic and parasympathetic nervous system communicate with the gut's own rich nerve supply, which is called the ENS, enteric nervous system. You probably didn't know about that. Look it up if you want to know more about it. Very, very interesting. And this network has been termed the gut-brain axis. The ENS contains 100 million neurons and regulates the motility, exocrine and endocrine functions and microcirculation of the gastrointestinal tract, which is very important for our gut to function, our body to function at our optimal level. So here you have a little graph which is really interesting. It talks about stress at the top, and it shows what happens in the hypothalamus, how it secretes CRF to the pituitary. The pituitary secretes ATH. It goes to the cortex, which supplies glucocorticoids, which is cortisol, and then also adrenaline, noradrenaline. But what happens also is there's a back and forth communication with the sympathetic and a parasympathetic nervous system with the enteric nervous system, which is the gut, and it goes like a little cycle. It's an ongoing system. So this back and forth communication between your brain and your gut is known as the gut-brain axis and occurs primarily along an information superhighway called the vagus nerve, which is very important. I'm pretty sure I did an episode on the vagus nerve, or I'm going to do an episode of vagus nerve if I haven't. Absolutely amazing nerve. So stress is bad news for the gut-brain axis, okay? It's like error, stress is happening. The gut-brain axis goes into activation, and the stress signals trigger the release of neurotransmitters and pro-inflammatory cytokines. So this is the ones that cause inflammation and essentially cause disease, which affect the gut in all kinds of ways. So what stress actually does on the gut is crazy. So to name a number of them is it causes intestinal dysmotility. So that's when the muscle and the nerve of the digestive systems don't work properly, which you're just thinking about that. How many diseases does that cause? Numerous amounts of them. It also causes holes in the intestine, allowing toxins, bacteria, and food particles to escape in the entire bloodstream. Think about that. Food sensitivities is one of them. An imbalance in your gut bacteria, small intestinal bacterial overgrowth, decreased blood flow and oxygenating to the gastrointestinal tract. No blood flow, what does that mean? So many issues. Acid reflux, absolutely so many of us suffer from acid reflux, and it may be due to stress affecting your gut. Within each human gastrointestinal tract, there is an exclusive combination of different communities of organisms, such as our bacteria, our viruses, and our fungi, which collectively refers to the gut microbe, which you've probably heard about before. So this actually outnumbers the total amount of human cells in the human body. There's more bacteria cells in our body than our actual cells. So are we bacteria or are we human? Another question. The collection of these microorganisms and their genes are effective produce all part of the gut microbe. So increased evidence suggests that microorganisms actively participate in shaping and maintaining our physiology almost at an extra organ. So it's kind of saying this bacteria is kind of like an extra organ that's making us function. So a lot of disorders in the gut, such as irritable bowel syndrome, inflammatory bowel disease, are associated with an imbalance of these bacteria in our body. So there needs to be a diversity for it to function properly. So the gut microbe helps break down food. What it also does is it helps produce metabolites that can directly influence the physiology of host cells, including brain cells. Moreover, immune response to pathogenic bacteria produce cytokines that affect brain psychology. So this is also saying that if your gut microbe isn't the way it's supposed to be, it can impact your brain, anxiety, depression. Think about it. Because the nervous system is a master regulator of host functions, this allows microbes to influence a broad range of complex psychological processes. An improved mechanism understanding of how bacteria molecules act on the nervous system could yield improved therapeutic for treating behavioral and neurological disorders. This is a huge study to be thought of, because if we can impact our gut bacteria, imagine how much we can impact our brain. And if we can impact our brain, imagine how much we can impact our gut bacteria. So the communication between the gut microbes and the central nervous system occurs in a bi-directional fashion, which means if the top talks to the bottom talks to the top. It's ongoing, it's bi-directional, and it's referred to as the gut microbe axis. The ENS, which is the enteric nervous system in the gut, as well as the sympathetic and parasympathetic nervous system in the central nervous system, plays major roles in the communication within these axes. So here we have another photo, like I love little graphs. Okay, so we've got the brain. We can see that there's the vagus nerve, the gut microbe at the bottom. We can see the circulatory system, the immune cells. So essentially the gut microbe brain axis. So the gut microbe can influence the brain function through a variety of mechanisms, including the production of neurotransmitters and short-chain fatty acids, which we can see in this graph. The modulation of the release of cytokines by immune cells and the vagus nerve, you can see in the graph also. Conversely, the brain can influence the gut microbe via regulation of the endocrine system, such as the HPA axis. Absolutely interesting. I love these little graphs. So your gut is home to trillions of microbes that all work in harmony. So they all want to work at a level. They all want to provide the best thing for you to keep you thriving. So 80%, but also the interesting thing is about 80% of your immune system is actually in the gut, affecting almost every aspect of how you feel every day. So when your gut is healthy, a lot of people go, oh, good bags, bad bugs, so forth. So when your gut is healthy, it contains a solid balance, about 85% of the good bacteria and 15% of the bad bacteria. So yes, that's right. We also need some of that bacteria to balance it all up. That's so-called the bad guys. We need some of them too, but it cannot be more than 15% because that's when the issues occur. So the 85% of the good bacteria in your body helps you feel and function at your best. So what it does is, just to name a few, it does so much more than this, okay? So it supports your immune system. It digests your food. So by digesting foods, it means you're intaking the vitamin, minerals, and vitamins that you need for your body to function. Supports your mental clarity, promotes nutrient absorptions, which is what I said, balances your hormones, normalizes your glucose levels, supports a healthy gut barrier, regulates inflammation, doesn't reduce it, it regulates it, it wards off pathogens and disease-causing microbes. And this is just to name a few about what these good guys do. So we need 85% of them in our gut to function. This is a really interesting study. I thought I'll chuck it in here. So the study looked at 40 healthy women and put them into two groups based on their gut microbe. So, and the way they tested them is they took their poo samples and they said, okay, you have good, okay, you have bad, let's study you guys. The women with a prevalence of one type of bacteria reported feeling less anxious, stressed, and irritable after looking at negative images compared to the other group whose guts were dominated by a different kind of bacteria. These scans also showed differences in the women's brains. Those who said they felt less stressed showed lower brain volume in areas like the hippocampus than the other group. So this is just showing to us that different types of gut bacteria affects our mood, affects our brain, affects how stress impacts us. Like, think about that. Your bacteria decides how stress is going to impact you. If that stress is going to impact you in a positive or negative way, if that's going to cause that stress disease or if it's not. Okay. So now that we understand the gut and microbe and what it does to our body and how it assists with our body's function, let's get into to understand how stress actually impacts the gut. Let's look into it. I'm excited. I'm so excited for this episode. Absolutely love the gut-brain axis. So the effects of stress has on the gut. The majority of effects of stress on the gut psychology include 1. Alterations in gastrointestinal motility, increase in visceral perception, changes in the gastrointestinal secretion, increases in intestinal permeability, which is bad, negative effects on regenerating capacity of gastrointestinal mucosa and mucosal blood flow, and negative effects on the intestinal microbiome, which is what we just spoke about. We just spoke about how important the microbiome is, and this is saying that stress impacts it in a negative way. Stress causes changes in the composition of the microbiome, including changes in neurotransmitters and pro-inflammatory cytokines levels, which could directly or indirectly affect the microbiota. For example, no epinephrine, which is increased when we're stressed, increases the presence of the bacteria called E. coli. Gut microbes may modulate the sensation of pain, and some probiotics may inhibit the hypersensitivity and perhaps the intestinal permeability caused by the body's exposure to stress. So if we have high E. coli, it's actually, studies show that it's not that beneficial for us and our body because it causes havoc on our body. So we can see that stress increases this bacteria, which is not good for us. Here I have another little graph. We'll go on this side this time. This graph is absolutely amazing, right? So it shows to us that pathopsychological consequences of disrupting the gut-brain axis by stress. Okay, so we can see we have stress, it impacts. So the exposure of stress leads to disturbance of the gut-brain axis, resulting in the development of different diseases of the gastrointestinal tract, including, we can see up there, GERD, peptic ulcers, IBS, dyspepsia, and other functional GI disorders, inflammatory bowel disease, and food allergies. So we can see that stress impacts and causes all of these things, which we're going to go into now. It's so interesting. So I want to talk about how stress can impact and cause these different types of diseases in our gut. The first one and the most common one that if you don't have it, you would have had it in the past, or you know someone who has it, reflux. Reflux, it's widely spoken about in Australia. A lot of individuals suffer from reflux, known as gastroesophageal reflux disease, known as GERD. It represents one of the most important manifestations of stress exposure to the GI tract. It has been shown that stress causes the aggravation of GERD symptoms due to the inhibition of the lower esophageal sphincter and increases sensitivity to acid. So that is the issue. The issue is not the acid, the issue is the sphincter. An increased perception of acid. On the other hand, the reduction of stress may lead to an improvement of GERD symptoms. Interestingly, during stress exposure, the amount of reflux does not always increase, but the probability of feelings of reflux as heartburn increases. Generally, the treatment for GERD, especially for those who are not responsive to PPI, requires further evaluation and potential effects of stress on patients who are on PPIs. And we know the effect that PPIs have on our gut and some individuals in their head also, which causes a lot of depression and anxiety symptoms. So this is GERD. So this is showing to us that stress increases reflux. The other one is peptic ulcers, another gastrointestinal issue that a number of us have and suffer with. Exposure to a stressful life event may provoke the development of peptic ulcers. Ulcers patients are more likely to be divorced, separated, or widowed. That's really interesting. Despite the fact that Helicobacter pylori and non-steroidal anti-inflammatory drugs, NSAIDs, are the important cause of peptic ulcers, it's been shown that stress exposure may contribute to this disease and may cause more peptic ulcers and ulcers to be developed. Possible causative factors include, and this is where stress comes in consideration, the alteration of gastric acid secretion. What does stress do? It impacts that. Reduced muscle blood flow. What does stress do? It impacts that. Reduced HCO3 secretion. What does stress do? Impacts that. Acid back infusion. Reduced proliferation and restoration of the injured mucosa. Alteration in gastric motility. What does stress do? It impacts that. So stress impacts those parts. With those parts cause the peptic ulcer. So is it the middle part or the stress? Well, I would say it's the stress that causes it in a sense, because we're going to look at the root cause, not the first cause, if that makes any sense. The other one that we're going to go into is IBS. One of the most important diseases of the GI tract that's linked to stress exposure to the gut is IBS, irritable bowel syndrome, which represents a common but complicated and misdiagnosed, there you go, gastrointestinal disorder with a worldwide prevalence of between 10 to 20%. So in the world, 10 to 20% have IBS. Females are more common than males to have IBS. It is a functional disease and is mainly based on the exclusion of organic disease. So it's kind of like when you go to a doctor, they have a checklist and they go, okay, you don't have this, you don't have this, you don't have this. Okay, you have IBS. That's how you're diagnosed with it, hence why so many individuals have it. It is categorized by periods of flare-ups and periods of remission. One of the most common symptoms are diarrhea, constipation, abdominal pain, and bloating. What happens when we're stressed? We get all of those, okay? So think about how stress impacts individuals who have IBS. So stresses may lead to flare-ups or exacerbations of the complaints. So the disruption of the brain-gut microbe axis as a potential pathophysiological cause of irritable bowel syndrome. Okay, stress is associated with the development of irritable bowel disease. The activation of brain-gut axis leads to the changes in the visceral sensitivity, changes in the release of gastrointestinal hormones and neurotransmitters, increased expression and release of pro-inflammatory cytokines, changes in the gastrointestinal mobility of the gut. And that's the graph up here that shows to us what stress does. It causes all those things that I've spoken about, changes in the microbiota, motility, immune function, and then that is the cause of irritable bowel syndrome. IBS. The other interesting one is that a lot of people would not have thought about stress impacting the gut is food allergies. How many individuals are allergic to food or sensitive? I should say sensitive to food, right? sensitive to food, so many of them. So recent years have been marked as an increase in food allergies prevalence among children, particularly in the Western countries. That cannot be explained by genetic factors alone. Food allergy is an immune-mediated adverse reaction to food. This is food allergies we're talking about, sorry, not sensitivities. Thus, considering the candidate's risk factors have begun to focus on environmental influences that disrupt the healthy development of the emerging immune system during critical periods of development. So this is particularly in the gut. So this is saying that it looks at prenatal, during childhood, what can impact them to have these food allergies. In rats, they have provided conceiving evidence of acute and chronic stress exposure altering intestinal barrier function. Studies have shown that acute stress, typically in the form of resistant stress, increased epithelial permeability in the rat's intestine, resulting in a greater ion secretion and macromolecule uptake across the epithelium. For example, commonly used model proteins such as horseradish peroxide compared with non-stress controlled rats. Additional data have suggested that the increased epithelial permeability after acute stress exposure may be due to, at least in part, to an increased release of CRH, which is the cortical releasing hormone, which has got to do with stress. That's released as the first thing before cortisol is released. Studies outline the role of psychological stresses on epithelial permeability in the gut and suggest that exposure to stresses may increase the transepithelial passage of food antigens into the intestinal mucosa, thereby increasing the risk of adverse reaction to these foods. The intestinal microbiota is increasingly being viewed as an important mechanism in allergy disease. Germ-free mice have been found to be more susceptible to cow milk allergies, suggesting that the microbiota may play a protective role in allergy susceptibility. This is saying the better your microbiota is, the less you're likely to have allergies to these foods that a lot of kids especially have allergies to. So, and that stress increases your gut intestine permeability, which means the food comes out, which means it gets attacked by the immune response, which means, oh no, we want to release it, we cause an immune reaction, allergy reaction. Wow. The other one I wanted to talk about is, I'm talking about so many, I think this is the last one, is inflammatory bowel disease. And a lot of individuals, unfortunately, have this, which is ulcerative colitis and or Crohn's disease. And these are chronic. These are relapsing remitted diseases. The etiology of both diseases involves a complex interaction between genes and environment. Experimental stress in animals increased intestinal mucosal permeability and also altered bacterial host interaction. These changes are likely to contribute to mucosal inflammation and fit the hypothesis that such inflammation is driven by mucosal flora, which is affected by stress. Recent studies indicate that chronic stress, adverse life events, and depression can cause relapse in these patients. Effects of stress on inflammatory IBD are likely to be mediated through changes in HPA function, alterations in the gut microbiota, activation of mucosal mast cells, and peripheral release of CRH, which is impacted by stress. In recent years, however, considerable evidence has accumulated that psychological stress does indeed contribute to the risk of relapse in IBD. So, there you have it. There is so many things that stress causes in our gut. It's absolutely, it's mind-blowing. So what do we have? To start off with, we had GERD, which is reflux. We had peptic ulcers, IBS. We had food allergies, and we spoke about inflammatory bowel disease. These are all impacted by stress. So that is the way that stress impacts your gut in a negative way. So now you're thinking, well, what can I do now to ensure that stress doesn't affect my gut? I don't want to have a peptic ulcer. I don't want to have reflux. What do I do? Well, the number one thing that I always talk about, I've had a huge video on this and a lot of people have viewed it and I've had some amazing feedback, is sleep. Go to sleep and sleep deep. Not only does quality sleep help reduce stress and help you feeling your best physical and emotional, but research shows that it benefits your gut bacteria as well. In fact, any disruption to your innate circadian rhythm, including sleep, can throw off the rhythm of your gut bacteria, leading to a depleted microbiome. Number 1, sleep. Number 2, say no to antibiotics where possible. The key is where possible. Antibiotics are found in our foods as well as our medicine, right? They wipe out the good guys, the 85% of the good guys, and increase the bad guys, that 15%. Do your best to avoid meats, fish, dairy products that contain antibiotics, and check with your doctor to make sure that the antibiotics when you are taking are necessary and they're actually going to help you more than they're going to cause backflow. And talk to a health professional when you are taking antibiotics to ensure that you rebuild your microbiota back in place. Number 3 is support your good bugs. Prebiotic foods. Prebiotic foods are the foods that promote the growth of beneficial bacteria in your gut. They're mainly fiber or complex carbohydrates that can't be digested by human cells. Instead, certain species of bacteria break them down and use them for fuel. Included in fruits, vegetables, whole grains, they all contain prebiotics, and they can also be found on their own. Resistant starch is a prebiotic, which is absolutely amazing. So many studies have shown that prebiotics can promote the growth of many healthy bacteria. So there you have it, 3 things. Sleep. Avoid antibiotics where possible, not just taking them internally, but through the food that you're taking also. And 3, support your microbiome. Support those good guys so they can support you. So you know what? Stress is a major risk factor in the pathogenesis of different diseases in the GI tract, including reflux, peptic ulcers, inflammatory bowel disease, irritable bowel disease, and other functional disorders in the GI tract. Stress increases the intestinal permeability, sensitivity, alterations in the gut microbe mobility, and leads to profound mast cell activation, resulting in the release of pro-inflammatory mediators. So stress impacts our gut dramatically and causes so many issues. So can we reduce our stress? Yes, we can. Can we assist our gut? Yes, we can. Because them two, like I said, like the gut-brain axis, they talk to each other. So let them talk to each other in a positive way. Support your stress, support your gut so you have an optimal life. There you have it. Thank you so much for listening to this episode. If you love this episode, share it with a family, share it with friends, someone who needs to boost their gut microbe. Share it with them. Do what you do best. Love, like, share, review. Until next Monday, love you.